Hello everyone, my name is Mona Lisa. I am program manager at ZIGURAT. It's a great pleasure to me to see so many people here today. For those who don't know, Tarek is alumni for ZIGURAT's postgraduate program in Parametric Design with visual programming in BIM. Hi Tarek, how are you?
Hello, Mona. How are you? My name is Tarek Mallak. I am a mechanical engineer, electromechanical engineer, in fact. I decided I'm a BIM consultant at the moment, and I decided to start with this program because I wanted to expand my experience in creating Dynamo scripts, basically, and Grasshopper scripts in order to advance my knowledge and my services that I can offer to my clients in these areas as a BIM consultant and solution offers for my clients. I don't know if we can start right now by the presentation. Is there enough?
Yeah.
Okay,
Thank you very
then
much. It's all yours,
okay,
Tarek.
okay. Okay, so we will be talking today about the impact of parameterization and automation on engineering, specifically in production and construction. I am a postgraduate of the program in Parametric Design of Visual Programming in BIM, and you can actually scan the barcode if you'd like more info about the course. As a quick overview for this presentation, I will try to present what is automation and parameterization in BIM, a quick introduction about the visual and textual programming, and I would give the benefit of the combination of this textual and visual programming under four main facets. I will not go into details right now with these. I will talk about it later when it comes, and I will finish at the end by a quick idea on the generative design. What is automation and parameterization in BIM? If we want to give it a crude and a practical approach, it's just a relationship between a set of input and a set of output. As long as we can find this relationship and write it as an equation or find a process to do that, it can be automated. Parameterization, again, as a practical approach, is adding a human decision to that process. While we are running this automation process, the user can make some changes. In this example, the input number 3 can be varied. And this is the basic idea of what parameterization is. What is visual programming? As you can see in this example, we have a small example on maybe changing a circle, translated, changing its radius, changing its center. This visual programming is mainly built by components. These components are an open source that you can find anywhere online, basically. It's easy to use, it's very clear, it's easy to check, especially if you are making a lot of complicated programs. As you can see, it's easy to maneuver. And this is the main benefit from visual programming. If we take a look at the textual programming, on the other hand, textual programming is something that we can write. In this example is a Python. You can add it in C# or whatever language that somebody can use. In this example, let's say it's very versatile. It's a script that looks at the distance difference between fittings and ducts, for example. It's a random script that I have. It's very versatile, the textual programming. It uses less CPU memory, and it has an open source libraries. And for example, in Python, it's a language that is used worldwide with programmers. So you'd find a lot of functions, a lot of loops, a lot of classes that can help you create certain functions that can be defined to the specific project that you have. Now, combining these textual and visual programming can give us a lot of benefits. The first one that I'm going to start talk about is a standardized and quick production. Why do we need a standardized and quick production? We can start by maybe automation, that's the basic level. Automation and for repetitive tasks. In this example, you can see maybe we can create sheets. This is the video that is there by one click from whatever parameters that we add, which floors that we want to create sheets for, and just by simple click we can create these sheets. We can import, we can export to Excel or CSV, we can add installation, we can change material, all these redundant tasks that engineers and architects have that do not take a lot of process, do not take a lot of time, but actually not much decision making, can be automated, and that is easy to do. But also we can use that for more complicated computing, for complicated tasks. Let's say we want to create a facade, or maybe in this case that you're seeing here, a glass cover for a building. Maybe we'd like to ondulate it in a sine wave or exponential, I don't know, whatever the user would like. All of this is a humongous task to be done manually. However, with a small script that you can see here is a visual script, this shape can be edited, can be modified very easily. We can add also a steel structure for such things, maybe just by changing the number of edges or the radius of something. We can create a very complicated form, and that is very important in, let's say, for civil engineers or maybe architects, even for facades. Why do we use this standardized and quick production? What is the need for this? It minimizes the error and mistakes that we can do in creating any plan or any project that we have. It minimizes the production time and cost. Also, the training that is needed, because we do know that in order to give a uniform quality of everything, we need training that is consistent for every new employee that is coming, and even for all employees with that who actually forget some of the tasks. When you automate tasks, we can overcome these difficulties. And at the end, there is a huge importance and benefit in interoperability. However, I will not talk about this right now. That will come later when on its time. The second facet that I would like to talk about is the model flexibility. You can see here a small example where a building can be shaped, can change its shape by changing some of the parameters, and that is the origin of the word parametrization. We can change the level heights, we can change the number of floors, we can change the elliptical form of that specific building, for example. This is a great tool to use when we are in a concept design, or basically even in first stages, not only on the concept design, especially when we are talking to the client or we need to visualize options or scenarios for our projects. We can maybe add other things here. It's, as you can see in this example, a small script can maybe make a scale for these floors. In this example, I tried to give it an ondulation that is also based on sine wave that can change exactly by changing a parameter. That can help us maybe make a rotation, or even, and that's the most important thing, maybe a recursion, because that cannot be done manually. That is a very hard task to do manually. However, it's a very simple task to do with a script like this, especially if we know textual programming, because when we use Python, for example, you can find functions online that somebody else has created and that you can use in order to and twink a little bit with it in order to find a bigger and a holistic approach to your project. What this flexibility adds is a visualization to different scenarios. If an architect or an engineer trying to visualize something, it can help us to see a lot of scenarios in front of us. and that can be also that give us a quick response to our client's needs, because I think that architects know that a lot these days. When you go to a client and you want to propose your project, a lot of time you'll have a feedback and you'll have to go back and change, I don't know, floor heights, for example, or the number of floors, or in that example before, maybe the length of a building. Examples that are very that exist a lot in our trades. And so if we have such a program that we can present to our client, we can change our project right with our client to change the basic form of it, especially in the first stages of our design. And it allows us to do more complex forms, as you can see with a recursion or with a sine wave. I don't know, it's up to everybody's imagination at this point. Another facet, the third one, is a checkup for errors. I will not go into details in everything of this, but we all have to respect norms and standards in our trades, whether it's a separation distance or a floor area ratio, or maybe we have some constraints like gross area or a volume that we should not exceed or we should not go under maybe. And we have some errors and warnings that we would like to impose on ourselves, maybe a placement of things or duplication of tags or names that we don't want to have, or these are small mistakes that can happen when we are working, and it's easy to miss when we are focusing on the details of some task. So example here, we have I have added a volume warning to that script, and as you can see, when we change the number of floors to add to make it to maximize it at a certain point, if we exceed the certain limit that we have added, it will give us a warning, and that is a very easy way to know that we have made a mistakes in somewhere in our project. And the last facet, and that is the most important, is the information management. We live in the era of BIM, and that is information. Let's take, for example, a project that is throughout the lifetime of this project, we have a lot of stakeholders who will deal with this project, whether giving information or taking information from what we call a CDE, a common data environment. This common data environment is the whole model in the BIM approach. It contains every information that a contractor needs, or an architect that puts there, an information that maybe an architect adds to that model, maybe the MEP engineer will need, or the manager will take, or maybe the quality control has to check. So having a standardized information flow is essential to have a CDE that is consistent and that is working in a standard way throughout all of this life cycle of the project. We have I think that everybody who worked with the project on a delivery time knows that the handover documents always get missed. The guarantees don't get on time. The installation material, the installation manuals maybe arrive after the installation. And so creating this CDE with a standard information flow allows us to fix all these problems. And why do we do automation in this case? Imagine if you have to add a tag, or if you have to add every info on every piece of equipment in your model manually. That is an immense task, and that is even harder than doing it as a hard copy, as a lot of companies still do, because it's nearly impossible to do on a model these days. However, with an automated program, a script, we can do that very easily. We can add the URL, we can add the model of an equipment, we can add any sort of information we need to add to any element in our model. Another point, and that is very important, and that's what I wanted to talk about right now, is the interoperability. Interoperability is something that we can look at it in a way of accessing the IFC files, for example. The IFC files, we are still using these IFC files to transfer data from a company to another. However, accessing these IFC files per se is very important. If you look at this example, it is a simple IFC file that I have on my PC, and you can look at this basic wall that is selected. It has an object type, it has the placement of it, it has a tag, it has every single element, it has every single information that we use in Revit. In this case, it was made in Revit. Every single information that is there in Revit exists in the IFC model. So if we learn how to manage and how to access these files, we can access these files regardless of whether we use Revit, for example, or no. Some of us use Bentley, some of us use Archicad, some of us use, I don't know, whatever we like to use in our company. We cannot just get licenses for every software that is ever used in order to open our files. So accessing these IFC files is very important. Knowing how to manage these files is very important. If we look at this IFC schema, I'm not gonna talk. We're not gonna go into details in that. It's. I know how complicated it is. But if you look here, you can see that the wall has an owner history, a name, a description, a type, a placement. Exactly the ones that we saw in the previous slide. In this slide, we see everything. We see the name, we see the representation, and it all exists in this IFC schema. And as long as, and if we learn how to manage this, how to work with this IFC schema, we can work with the IFC file, we can work with the elements in the IFC file without opening the file per se in Revit or in Bentley or whatever it is. So if you look at something like this, it's called OpenBIM. It's a small script that works on slabs and levels and creates a schedule for it. This can be run from from the PC without the software, without Revit, without anything. It accesses the IFC file per se, and we can look at any type of info that we want to treat it in any way we want, and put it in an Excel sheet, or I don't know, whichever we like to, whichever way we'd like to present it. So this information management allow us to plan better, because we all, every stakeholder has an input on this file, on the CDE. So we do not miss information. Whatever constraints we have, anyone can say that they have these constraints. Anyone can put info there. Anyone can take info from there. Anyone can have a comment on it, whether it's the QA or the facility manager or the owner per se or the client. We can plan better as long as our model is shared by everyone, and everyone can access it in the same way, regardless what software they are using, whether they're using again Bentley or whatever. And that all causes smooth collaboration, because we do know right now, every one of us knows who works in this sector, that none of our project goes smoothly. We always have modifications that come very late in our production. We have to start all over again, because sometimes we do miss information that should have come to us from our colleagues, from other stakeholders, but we do not actually, and that is the reality of things. And also, and the great facet here is the future access, because I think also everybody would agree, everybody who worked on on a project will know that after a certain time, we change the project, we change the revisions that we have, we change, maybe we just drop a software that we use and start using another one. We lose our licenses in it. And then our client after 5 or 10 years comes back to a question with us, and we can't even open our own project. Nonetheless, so in this case, we do not know what kind of technology we'll have, what kind of software we have in the future. So in order to maintain this access to every single file, regardless of what software we use, it is incredibly important to know how to manage an IFC file. Okay, so I will try to talk a bit about generative design, and that is gonna sound a bit complicated maybe, but it is not if we go with it step by step. Generative design is an idea about designing a design tool. We can start by the script that we write starts by generating different solutions, different designs. It analyzes basically analyzes these designs based on some parameters and some goals that the user specifies in the script. So let's say we can, this example that you see there, it's taken from Autodesk website. It's a study of volume versus cost. So we want the most efficient volume and cost building. This generative design script looks at different varieties of scripts of designs, and analyzes what is the cost and what is the volume of each. And then it ranks the designs, these scenarios based on the goals that we put. And the fourth step, which is the most important thing in what is a generative design, is to evolve. And here, the generative design tries to evolve in a certain direction of scenarios where the most optimal ones are found. As you can see, there is a diversion of these models into certain points. At the end, I'm sorry, before the end, it comes the human decision, and that is the exploring of these scenarios. The user will have to interfere at this moment and look at these different scenarios and choose what is the most applicable one, what is the most optimal solution that they want, and that is not a task that the script can do on itself. And after taking this this decision, after knowing what solution we would like to take, we can integrate it in our model. And if this is a case that is it's a case study created by Evolve Lab for optimization for view orientation. Generative design basically is used to solve oppositional problems. Let's say we need to look functionality versus cost, or in a car park, maybe we would like to see how many cars we can fit in this car park, but at the same time we would like an ease of access for a luxurious, I don't know, a luxurious car park. Maybe you can take a school where we have some functionality that rooms have to be functional next to each other in a certain way. However, it's very important in a school to have fire exits, to have a small route for that fire exit. And these two different parameters are can be opposed to each other, exactly like this study that is shown here. This study is made by Evolve Lab. It's for optimization for view orientation. It is an orientation. What is the area? What is the rotation? What is the angle that we want in order to have maximum sunlight for example. And that is very important in order to make a good decision. And even these type of scripts, the generative designs, are even used in industry such as cars, right? These days for aerodynamic flow versus weight of the car, for example. And finally, I would like to thank everyone. And if there's anything that anyone should take from this presentation, is to maybe learn some programming, because that is always becoming the end goal of everything here.
Thank you, Tarek.
Thank
It's
you.
many thanks for your insightful
Thank you.
talk.
Thank
I
you.
really enjoy it.
Thank you.
So we have some questions here. Maybe we can do some questions now for you.
Yes, sure,
Yeah.
sure.
Okay. So
Yes.
the first one, from your point of view, what would to be the greatest advancement or improvement professionals working in the field of parametric design can expect in the next few years, in your vision?
Okay, so in the parametrization, we can actually see a variety of solutions, and we live in a world right now where we cannot afford to build just with any cost that we like. That has been the case for a lot of time, but right now we live in a very efficient, energy efficient world. We have to look for a green solution. We cannot just throw money away for any kind of project. We have to study the most efficient, and that is an incredibly important topic today. We need sunlight, and this view, what the last example of sunlight and the orientation, that is very important in order to maximize the sunlight in our offices. That would reduce heating, that would reduce the energy that we put on electricity. This is very important in today's world. Everything is changing towards that, and we cannot just simply do a scenario that we have in our head, because as we can see, we all can propose scenarios. However, seeing these variety of scenarios in front of us, all these solution, and every single one of them measured, that would give us a greater tool to pick the most efficient tool, most efficient design in our case.
Okay, so
Okay.
thank you. We have more questions here. Is Tarek Mallak.
Okay. Okay.
Do we follow the IFC schema to write a textual script in Dynamo? Revit is the first one.
So if you want to write a textual script in Revit, no, you don't follow the IFC schema. The IFC schema is simply to access the IFC files. If you want to access the IFC file in an open BIM manner, that is when you have to learn to navigate this IFC schema. However, if you would like to simply write a script on Dynamo, for example, you can go for you can just Google Revit API. That will take you to a website where you will look at how Revit was written, the classes of each element, and you can learn to navigate these elements in the same way that we navigate the IFC schema, but it's very different. It's much more easy. It's easier to learn. It's easier to use. So it's called the Revit API. It changes with Revit revisions. So maybe the 2022 is different from 2023, and that is why you need to always look on your scripts and just update them with every revision of Revit that you have.
Okay,
Yeah.
so, and the second one is generative design considered an AI?
Oh, okay. That is a very interesting question, actually. No, it's not an AI. It is not that. It has no machine learning or deep learning abilities in it. The evolving is simply taking a direction in it. I know it sounds a lot like an AI. However, it is not an AI. It takes a human approach at the end to take these decisions. It's just a matter of following parameters that the user will install on this script. It is not an AI. It's just simply a study of different scenarios and then picking the scenario that is optimal for our solution. It does not learn from its behavior.
Okay, so, and we have two more questions.
Okay.
What is the biggest challenge that you had to face when you completing the postgraduate course in parametric design at ZIGURAT?
Oh, okay. I know that this is not this is a very common thing in everyone who is working in construction. We are not coders, we are not programmers. So this is something we do not know exactly what is a data structure. We do not know how to work with such languages as Python or C Sharp. That is a hard task, I know. However, learning these is very important for starting this course. The course in itself is very straight. You can work on it. The material that is given is more than enough for everyone to learn the programming and to learn these textual and visual programming. However, if you would like to have an edge on how to write a script, you have to have more knowledge on these programs. If you can learn Python, if you can learn C Sharp, it will give you an edge in creating your script, because a lot of times you need to handle, I don't know, a list, or you need to handle a loop, a for loop, a while loop that is not easily done with a visual programming, that need to be textual. And here we engineers who work on this in this thing in construction do not have expertise in this area. However, I think that's very important to learn that.
Okay, thank
Okay.
you. So
Yeah,
we
you.
have another question.
Okay.
It's from Anastasia.
Okay.
With all the parameters with all the parameterization in engineering, what is the role of the human engineer in the future?
Oh, okay. Also, that's very that's very interesting. Okay, so if we look at the progress of our trade, we started working on paper, and then on 2D, 3D. Now we introduced BIM, and we're introducing parameterization after that. So at every single step, we created other type of jobs. Some jobs got obsolete, other jobs were created. It's very important for us to be to learn some adaptability, to adapt with the change of technology. It's not easy, I know, but this is duty in every trade. We always will create new jobs. We will always see new ways of thinking, and that will create example. The biggest example here is BIM. We have BIM managers, we have BIM collaborators, we have so whenever we create something new here, whenever some jobs get obsolete, but others are created. So I do not think that the engineers or the architects will go obsolete. However, our job will change from it was drawing before to managing a script maybe that can create a design for us.
Yeah, we expect it.
Yeah.
So
So,
maybe we'll have one more question.
okay.
I don't know. I'm waiting.
Anyone?
I think that you are very
Yeah,
clear.
okay.
So
Okay.
thank you, Tarek, for
Thank you,
being
Mona.
here today and share your knowledge with us. Thank you so much.
Thank you. Thank
Okay.
you. It was a pleasure. Thank you.
Thank you. Bye bye, everyone. Thank you. Bye bye.